So my project is all about Malaria Edge AI Detection. Now what's the case scenario here? Actually I was trying to build a model that can detect malaria using Edge AI technology, and of course with a normal Python framework like TensorFlow or PyTorch. So why this project? Simply because in every 2 minutes a child dies of malaria, and World Health Organization's WHO data showed that globally 3.4 billion people in 92 countries are at risk of being infected with malaria and developing disease. But the good thing is that early diagnosis and treatment of malaria can save lives and prevent casualties. So this was the reason behind creating this project. And the good thing about this project is that this project does not require you to download and install anything, and the specialty of this project is that this whole project is based on this one notebook. Everything that will be required to use Edge AI and and a PyTorch model, as well as the data, these all of the things are covered in this one notebook. So when you will click on this notebook.ipynb file, it will take you to the notebook, and I have also included the Google Colab link so that you can just click on that button. This kind of button will show, and when you will click on it, it will take you to a notebook which will show like this, kind of like this. Okay, so just to save your time and minds, I am just switching directly towards this notebook, or else when you will click here, it will take you to the notebook itself. I'll definitely drop the links in the description of this video so that you can also look at these files and can play with it, especially this notebook. Okay, so first thing is drive mounting. When you will drop down this tab, it will give you this cell. What this cell will do, it will mount your Google Drive with this notebook. Okay, and second thing is the model work. So I have used fast.ai for this case scenario. What is fast.ai? Fast.ai is a library of PyTorch. It's a Python based library based on PyTorch framework. Okay, and how to install fast.ai? Simply you can write down _pip install fast.ai, and it will install fast.ai in the Colab kernel. Afterwards we will import vision module and metrics module from fast.ai, and this is the batch size 64. Then we will download the data, and data which I have taken is from NIH. What is NIH? NIH is a government organization, and this data is publicly available for all, so there is no need of worrying whether there are certain conditions and limitations of using this data. Of course you have to follow the terms and conditions. You can visit the NIH website. I have dropped their link also in the readme of Malaria Edge Detection project at GitHub. So in this cell we are getting the data, then unzipping the images. So what are these images? These images are blood samples. We are making directories. Let me show you the blood samples also. So we are setting the path, and this cell is very important, image data bunch. What it is doing, simply it is taking how many like pictures, like 0.2 means 20% should be used for validation purposes, and the other ones should be used for the training purposes, and this dot normalize means that we are normalizing our data. Fast AI, of course, with the name, it shows that it makes a developer lives a little bit easy, and of course making the use of AI fast. Okay, then here we come to fast AI network creation and training. Okay, so create a fast AI network for transfer learning. Awesome. So here what we are doing, we are creating a CNN model. Okay, the model is of RESTnet 34, and the metric I have used is error rate. So we are first of all downloading this model. This is the link of PyTorch, and then we fit, and the number of cycles we are using, you can say epochs, 4, and after 4 epochs, what we are doing, we are converting this fast AI model which we just trained here into ONNX conversion. So ONNX is a format. Why we are doing this, I'll tell you later on. So we have imported these packages, and then we have given them a dummy input ONNX path, and then simply using these lines torch.onnx.export, we have converted our model and exported it to this path. Okay, content/model fast AI.onnx. I'll tell you how you guys can also access this model file. So afterwards, we are going to retrieve the activation function, which is used to reproduce the same activation after network output. Okay, so here is the network output, and we are creating label files, and we are also exporting the stats to normalize the image. You guys of course can read more about these functions in the fast AI documentation. Afterwards, data visualization comes. So these are those blood samples that I was talking about. So since you guys can understand from this folder that parasitized, which means that these are the infected blood, so of course you guys can see the infection. So after visualizing these 4 images, just for making sure that we are going towards the right track, we went towards fast AI based inference. So I just called that predict method, and it managed all of this stuff on its own and gave us these results on these 4 input images. So identified whether they are parasitized or not, and what are the probabilities. Okay, then here comes the OpenVINO installation and operations. Now, what is OpenVINO? OpenVINO is an optimization toolkit, so that what this OpenVINO toolkit does, this OpenVINO toolkit converts your pre-existing models into an IR image, so that they can be optimized to be used in Edge AI applications. So here we come. Usually why this thing is needed, because normally users who are using models like locally, not on the cloud, does not have that much capable hardware that can support huge computing. So Edge AI makes it easy for them to use good models without getting much into like hardware resources. So this is an OpenVINO-Colab package. It's a Python package available on PyPy. So what you can do, you can just pip install OpenVINO-Colab. A fun fact that I have created this OpenVINO-Colab package. It is also recognized by Intel officials. so nothing to worry about. So you just have to pip install OpenVINO-Colab and then import OpenVINO_Colab. When you will import it, it will ask you to enter which format do you like to work on. So it will install only those format files. So here we have TensorFlow, we have MXNet, we have ONNX, Caldi, and fifth is all option. Like if you want to try out all of them, you can submit fifth option. Since I have already converted our fast.ai model to ONNX format, because fast.ai is based on PyTorch, and PyTorch is not directly supported by OpenVINO, but if PyTorch can be converted into ONNX, then PyTorch models can be used for OpenVINO IR conversions. So I have entered 3 for the ONNX format, and then installation is finished. Nothing to worry about, nothing has been done locally, everything is on cloud and free of cost. And then I have mentioned here some variables. I have declared and initialized them here. Then here comes the ONNX installation part. So I have installed ONNX, and then I have created an IR image, and afterwards I have run an inference on them. Why and how? So creating the IR image, the intermediate representation image, is very simple. You just have to run this cell, and afterwards we have to create an infer.py file. So nothing to worry about, you don't have to write down any code, you just have to run these cells. And what this cell will do, it will create a file with the name of infer.py, which will be used for the inference purposes. And now here comes the final inferences part. So I have used my infer.py file and my fast AI model, and then these and here I mentioned the labels which I made above, and here are the images path, and 0, 1, 2, 3 are simply calling the first image, second image, third image, and fourth image randomly, of course, in order to find out the inferences. So here it comes, these images are inputted into the model, and then the model gave inferences on them. So here is the first image, here is the probability, and here is the label. So the first image is 0.9366805. This is the probability. On second, this is the probability 98%, 98%, 99%. So, and of course with identifying the labels. So this was my work, and I personally would like to thank Mohammed Huzaifa for this ML02 Hero whole session. Like for those 30 classes, I mean, the whole session was really awesome and full of learning. Thank you so much for teaching us. Thank you once again, and it was an amazing experience to be in your class and learning from you. Thank you very much. I hope you like this project. Okay then, take care all of you, and thank you once again. And one thing, if you think that my project is worthy enough, do like this project and start it. Okay then, I'll take your leave now. Have a nice night and day. Where are you watching from?